Hi all, welcome back to my YouTube channel. So in today's video, we're going to start with a new chapter, Arithmetic Progression, chapter number 5. Chapter number 5. Okay, so in this video, we will learn what is the concept and also we will see the book examples. And in the next video, we will see how to solve exercise 5.1. Okay, this chapter is a very easy and also a simple concept. Basically, this chapter is about the number patterns. I've taken few keynotes and also examples from the NCERT. Now let's get started. Now here we are given a list of numbers. There are basically 5 examples are there. And by just looking at the series, okay, can we just say what will be the next few terms of in the list? For example, we will start with one by one. Okay, in the question example 1, the numbers are 1, 2, 3, 4. So obviously the next number will be 5, 6, 7, and so on. Okay. How is it we are getting? Basically, we are adding 1 to the preceding term. So 1 plus 1 will be 2. 2 plus 1 again will be 3, then 3 plus 1 will be 4, and so on. So this is easy one. Now let's take the next one in example 2. So the numbers are 100, 70, 40, and 10, and so on. Okay. So basically 100 minus 30, we are getting 70. Again 70 minus 30, we are getting 40. 40 minus 30, 10. So 10 minus 30 will be minus 20. Okay. Again, minus 20 minus 30, the next term will be minus 50. So again, minus 50 minus 30, it will be minus 80 and so on. So basically, for every preceding term, we are taking away 30 in this one. Okay, now example number 3. What is example number 3? The example number 3 is minus 3, minus 2, minus 1, and 0. So what is it we are doing here? So minus 1, minus 2. Basically, we are adding 1 again. So minus 3 plus 1 will become minus 2. Minus 2 plus 1 will become minus 1. So minus 1 plus 1 will become 0. Again, add 1 to it. So the next term will be 1. Again, it will be 2. If I add, again, it will be 3 and so on. Okay. Now, example number 4. So in example number 4, the series is just 3, 3, 3, 3, 3. So again, there is no change. It will again continue to be 3, 3, 3, 3 only. But then here, what is a number which is added or subtracted? If you notice, the number will be just 0. So basically, if you do 3 plus 0 is also 3. Or if you do 3 minus 0, that is also 3. So here the pattern goes by plus 0 or minus 0. Okay, either we do plus 0 or minus 0. So basically, the difference here is just 0. Okay, now the last example, example 5. So example 5 is minus 1.0, minus 1.5, minus 2.0, minus 2.5, and what will be the next term? How is it they're getting? So basically they are adding minus 0.5 to each term. So minus 1.0 minus 0.5 will give me minus 1.5. Okay. So again, minus 1.5 minus 0.5 will give me minus 2. Again, minus 2 minus 0.5 minus 2.5. So again, I will do minus 0.5, which is actually 3. So minus 3.0. The next one will be minus 3.5 and so on. Okay. Now, what do we notice here? Basically, here, there is some difference. Okay. There is some pattern which is going on and the numbers are same. So in the first case, it was plus 1, plus 1, plus 1. Second case, it was minus 30 throughout the series. Again, plus 1. And in the fourth one, it's a peculiar one, which is actually 0. So here, the common difference is actually 0. And in the last case, if you notice, it is actually minus 0.5. Okay. So each of the terms in this list is called as a term. So each of the numbers in this list is called as the term. Okay. Now we will see what is the definition of the arithmetic progression. So in all the list above, we see that the successive term are obtained by adding a fixed number to the preceding term. Such list of number is said to form an AP. So an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. So basically, we are adding a fixed number to the preceding term except the first term. Obviously, the first term will be the starting point. Okay, but then after that, so there is a fixed number which is being added to the preceding term. But then the fixed number can be anything, right? So in the first case, the fixed number was just 1. In the second case, the fixed number was negative 30. In the third one, again, it was plus 1. In the fourth one, it was actually 0. And in the fifth one, it was negative 0.5. Okay. So again, we will see what is the definition of the arithmetic progression one more time. So an arithmetic progression is a list of numbers, okay, list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Okay, clear? This fixed number is called as a common difference. Okay, so this is usually the common difference is usually denoted by small d. It's called as the small d. Okay, so this fixed number is also called as a common difference of the AP. Remember that it can be positive, negative, or zero. Yes, obviously, right? So in this example, we saw so one is positive, one is negative, and here the common difference d was actually zero. So the common difference is called as a d. Okay, and it can be positive, negative, or it can be zero also. I hope this is clear. Now we'll move on to the next point. Now, basically, how do I find what is D here? Okay, now how do I find what is D? How do I find what is this? What is the common difference? Let's take any one example. Okay, we will take example 2. So the example 2 here is basically, so here the example 2 is 100. Okay, then this is 70. Now this is 40. This is 10. So each number here is called as a term. And now we are going to find what is D. How do I find D? Now we will say this is the first one, which is A1. Okay, now second number is called A2. Third number is called A3 and fourth number A4 and so on. How do I find D? So we should find A2 minus A1, which is what is A2 here? Second term. So second term minus first term, which is equal to negative 30. Okay. And this negative 30 should be constant throughout, this should be the same throughout the series. Okay. Now again, we will try for the next two consecutive numbers. So again, I should find A3 minus A2. A3 is 40 and A2 is 70. So 40 minus 70 is minus 30. Okay. Now let's move on next, go to the next consecutive. So A4 minus A3. So A4 is 10. So 10 minus 40, which is equal to minus 30. So D here will be minus 30 and it is a same. Okay, now how do I find what is the common difference? So I will do A2 minus A1, or we can do A3 minus A2, or we can do A4 minus A3 if there is A5 and A6 and so on. So we'll have to find A5 minus A4 or A6 minus A5. And this one, the D for an arithmetic progression, it will be same throughout the series. Okay, clear, easy? Okay, now the next point. Now there are a few more examples now. Some more examples of APR, so and so and so. Okay, finally, we will just take my first example. The heights of sum of students of a school standing in a queue in the morning assembly are 147, 148, 149, and so on till 157. What is it we can see now? So basically now what we are going to see is there is something called as a general form of an AP. Now what is called as a general form of an AP? Now if we know what is A and what is D, we will be able to form an general form of an AP. How? So the first number will, the first one term is also always called as an A, right? Now how do I get the second term? Basically I am adding the different, or I am adding the common difference. So the second term will be A plus D. Okay. And the third number will be, basically I'm the second term, again I'm adding D. So that will be A plus 2D. Okay. And again to find what is the fourth term, I'll be again adding D to the third term. Now that will be A plus 2D plus D will become A plus 3D and so on. Now this is called as the general form of an AP. What is the general form of an AP? The first term will be A. Then the second term will be A plus D. Third term will be A plus 2D. Fourth term will be A plus 3D and so on. This is called as the general form of an AP. Okay. So in all the 5 examples, if you notice, we will just see one example. Let's see what is A and also what is D. Okay. Now we have started with this example. So basically here the first term is 147 and 148 and 149 and so on till 157. So basically what is D here? We are adding 1. So plus 1 plus 1 plus 1 is the D here. So the D difference is plus 1 plus 1 plus 1. Okay. Now let's say this is 147. Okay. A. Now what is A plus D? A plus D is 148. And what is A plus 2D? So 148 plus D. So that will become 149 and so on. Okay, clear? Fine. Okay, then there is one more thing. So what is called as a finite AP and what is called as an infinite AP? Now what is called as a finite AP? Finite AP is a one, like in this given example, if you notice, in this one, there is a last term. Basically, this series will end by 157. This is called as a finite series. In some series, if you notice, it will be just dot 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 dot. Even in fact, if you see the previous one, if you notice here there is just it is just a continuation. It's not stopping. So those are called as an infinite AP series. Okay, fine, clear. Okay, now let's start with the next one. Okay, now let's see what is. There are two common scenarios which we can actually see. Now this is the first one, scenario number one. Now let's say this is scenario number one. For instance, if the first term of an AP is 6, okay, and the common difference is D, then the AP is. So if in the question, if they will give us what is A and also what is a common difference, which is D, will we be able to form the AP series? Now let's give it a try. Now let's use the general format of the AP, that is, which is A, then A plus D, then A plus 2D, then again A plus 3D, and so on. So here the first term is A. It's very easy for us. So 6. Now what is next one? A plus D. Basically, you'll have to add. Here D is a positive one. So A plus 3 will be, that is 6 plus 3 will be 9. So the second term will become 9. Again A plus 2D. That is A plus 2 into D. What is A here? So A is actually 6. So 6 plus 6 will become 12. Okay. Then again adding 3 to this will become 15. Again adding 3 to this will become 18. Then again adding 3 to this, then that will become 21 and so on. So this is the arithmetic progression. Or we can use this one also. Okay, so basically A will be 3, A will be 6, then 6 plus 3, then again 6 plus 2D, then again 6 plus 3D. So 3 into 3 will become, so 6 plus 9, so that will become 15. So if you notice, the first term will be 6, then 9. So it's 9 here, 6 here, 6 is the first term. So 6, 9, 12, 15, and so on. Okay, clear? So first scenario is clear. There are a few more examples. So now A is minus 7 and D is minus 2. Now how do I form the AP series? So AP series will be, now how do I form the AP series? So that is A, then A plus D, A plus 2D, A plus 3D, and so on. So the first term is actually minus 1. Let's start one by one. So this is minus 7. Then minus 7 minus 2 will become minus 9. Minus 9 minus 2 will become minus 11. Minus 11 minus 2 will become minus 30, and so on. So our AP series will be minus 7, minus 9, minus 13, minus 11, minus 30, and so on. This is the first question. Now what is the second one? This is question 1, question 2, question 4. Okay. Now for the second question now. Now for the second question, A is actually 1.0 or just 1. Okay, so A is 1 and D is 0.1. So basically we'll have to add 0.1 to the preceding term. So 1 plus 0.1 is 1.1. 1 plus 1.1 plus 1 will become 1.2, then 1.3 and so on. Okay, third question. Now A is equal to 0. Okay, the first term has become 0 now. And D is equal to 1.5. That is basically a mixed fraction. So 0 plus 1, 1 by 2. So that will become 2 ones are 2, 2 plus 1, 3. So 0 plus 3 by 2, which is equal to 3 by 2. So the first next term will be 0 plus 3 by 2 will be 3 by 2. Okay. Now what is the third term? Basically, again, we'll have to add 3 by 2 plus what is the difference here? Again, 3 by 2. So 3 by 2 plus 3 by 2. That becomes 6 by 2, which is actually 3. So the next term will be 3. Now again 3 plus 3 by 2. So now what is 3 plus 3 by 2? So 3 plus 3 over 2. Let's take an LCM. So 2, then 6 plus 3, that will become 9 over 2. So the next term will be 9 by 2. Okay. And so on. So again, if you add 3 by 2 this one, then you will start getting the next term. Easy now? Well, let's start with let's solve the fourth example here. The fourth example, A is actually 2. Fourth example is very easy. So basically A is actually 2. Fourth example. Okay, so A is 2. So the first term is 2. And D is actually 0. So basically 2 plus 0 will become 2. Again 2 plus 0 will become 2. Sorry, I've done 0 here, but it's actually 2. So again 2 plus 0 will be 2. So the series will be just 2, 2, 2, 2, 2. So again, if you notice here in the first one, D is actually negative. Okay, in the second one, D is positive. So, and in the last one, D is actually 0. So D can, very important point. So D can be positive or D can be negative or D can be 0 also. Right? The one important thing for AP is that the D should be same for the throughout the series. It cannot be different. If it is different, then it doesn't come under arithmetic progression. Okay, clear? This example, so scenario 1 where we will be given what is the first term and the difference. So now we should be able to form an arithmetic series. Okay, and also the general form of an AP series will be A plus D, A plus 2D, A plus 3D, and so on. Okay, now next one. For example, for the list of this one, okay. Now, for example, now this is the second scenario. Now, what is the second scenario? Second scenario is basically they will give us the AP series. Now, we should be able to find what is A and what is D. This is scenario 2. In the second scenario, we are given the AP series. Okay. Now, we'll have to find if what is what is A and what is D, and also we'll also see what is if this will form under AP category. Okay. Now, let us see now. Because in the question, they have clearly given you, for example, for the list of numbers, they have not given us in the given AP series. Okay, so they have just given the list of numbers. And we will first find what is A, we will find what is D also. And if D is same for throughout the series, then it forms an AP. Now, let's check now. So, in this one, A will be 6. That's the first term. And D we'll have to find. How do I find D? The number is actually, the list is 6, 9, 12, and 15, and so on. Now let's say now this is A1, this is A2, A3, and A4. So according to this one, D should be A2 minus A1, or it can also be A3 minus A2. We can also find by A4 minus A3. Any two consecutive terms we should take, but then it should be same. So now A2 minus A1, 9 minus 6 will be 3. A3 minus A2, 12 minus 9 will be 3. Okay. Then again, 15 minus 3, 15 minus 12 will also be 3. So if you notice, D is actually the same. So this forms an A. And here A will be 6 and D will be 3. Okay, now next example. For the list of numbers 6, 3, 0, and minus 3. Now let's say. So the numbers are 6, 3, 0, minus 3, and so on. Here A is equal to 6. Okay. And let's find what is D. This is A1, A2, A3, A4. So how do I find D? A2 minus A1, or it can be A3 minus A2, or it can be A4 minus A3. Now what is A2 here? So A2 is 3. 3 minus 6. That is 3 minus 6 will be negative 3. Okay. Now again, A3 minus A2. So A3 is 0 minus 3. So minus 3, correct. Okay. Now what is A4 minus A3? So A4 is negative 3 minus 0, which is actually minus 3. So this is also forms an AP. Here A will be 6 and D will be minus 3. Okay, clear? Let's move on to the book example now. Example number 1. For AP, this one. So they have given us a series and it's an AP. Write the first term A and the common difference D. So obviously the first term is very easy to find. Here the first term should be, this is 3 by 2. So A is 3 by 2. Now we should find what is the common difference for each and everything. Okay. So this is easy now. So A is equal to 3 by 2. Now to find D, we will just write the series. So 3 by 2, 1 by 2, then again minus 1 by 2, then minus 3 over 2. So this is A1, this is A2, this is A3, and this is A4. Okay. To find D, what we will do is, we will do first thing A2 minus A1. We will do A3 minus A2 and A4 minus A3. So what is A2 here? So A2 is half. So half minus 3 over 2. Half minus 3 over 2 will be minus 1, I guess, correct? Yep, minus 1. Then A3. So A3 is minus 1 over 2 minus A2. So A2 is 1 by 2. So which is equal to minus 2, then 2, then again this is also minus 1. Okay, then again A4 minus A3. What is A4? Minus 3 by 2 minus half minus 1 by 2, which is equal to minus 3 over 2. Minus into minus become plus. So plus 1 over 2, which is equal to minus 2 over 2, which is equal to minus 1. So if you notice, D is actually same throughout the series. So D will be -1, okay, and A will be 3 over. So D is -1. Okay, now we'll jump to next question. Question number 2, example number 2. Which of the following list of numbers form an AP? If they form an AP, write the next two terms. Okay. Okay. Now in this one, we are given a list of numbers. So the first thing we'll have to first tell them if this forms an AP series. If yes, then we'll have to find out what are the next two terms of the given series. Now, what is the condition to form an AP? That is a common difference D should be the same throughout the series. If they are same, then it forms an AP. If it is not same, then it's not, it doesn't come under the category of arithmetic progression. Okay, now let's take example number 1. So example number 1 is 4, 10, 16, 22, and so on. So there is no last term. If you notice, this is an infinite series. So obviously the first term is actually easy. The first term will be 4. So A is equal to 4. And what is D? So D is equal to, we will just name this one as A1, A2, A3, A4, and so on. So D is A2 minus A1 or A3 minus A2 or A4 minus A3. Since we are checking if this particular series will be forming an AP series, the answer which we are going to get in all the three things should be the same. Okay, so what is A2 minus? We can actually use any two consecutive terms. Not necessary that we'll have to use only these three. Okay, so we can choose any two consecutive terms in the series. So what is A2 minus A1? A2 is 10. 10 minus 4. A3 is 16. So 16 minus 10. Okay. A4 is again 22. So 22 minus 16. So 10 minus 6 will be 6. 16 minus 10 will be 6. 22 minus 16 again will be 6. So the common difference D is actually the same. So this first question forms an AP. Yes. So this one forms an AP. Okay. Now second example. So what is example? Subdivision 2. In subdivision 2, what is the question? So 1 minus 1, subdivision 2, it is 1, minus 1, minus 3, then minus 5, and so on. So A is equal to 1. Now let's find what is D. And for that, we will just write this as A1, A2, A3, A4. So for finding D, we will say A2 minus A1, A3 minus A2, and A4 minus A3. What is A2? A2 is minus 1, minus 1 again. Okay. A3 is minus 3, minus A2 is minus 1. So we will write within brackets. A4 is minus 5, minus of A3 is again negative. So we will write that one also within brackets. So minus 1 will become minus 2. Let's remove the bracket. So minus 3 plus 1 is minus 2. Correct. Then minus 5 plus 3 is equal to minus 2. Okay, so here the D is actually minus 2 and it's the same. So this also forms an AP. So this particular series also forms an AP, which is right. Now let's move on to example number 3. Now what is example number 3? So number 3 is minus 2, 2, again minus 2, 2 like this. Okay. So example 3 is basically minus 2. First term is minus 2, then 2, then again minus 2, then again 2, then minus 2, and so on. So the first term of the series will be A, which is minus 2. Okay. And D is, we will just write, this is A1, A2, A3, A4, A5. Okay. So here D is equal to A2 minus A1 or A3 minus A2 or A4 minus A3, A5 minus A4. What is A2? So A2 is 2. So 2 minus of minus 2. A3 will be minus 2 minus of 2. Okay. A4 is 2 minus of A3 is minus 2. Again A5 is minus 2 minus of A4 will be 2. So 2 plus 2 will be 4. Okay. Minus 2 will become minus 4. Then this one minus 2 minus of this will become minus 2 plus 2 will become 4. Minus 2 minus 3 will become minus 4. So if you notice here, the first one we are getting 4, then negative 4, then 4, negative 4. But then according to the definition, for a series to be an arithmetic progression, the D should be same. Okay, it has to, if it is 4, then it has to be a positive 4 throughout the series. If it is negative 4, then it should be negative 4 throughout the series. But here, if you notice, one is positive, one is negative, and so on. So what we have to tell them is, we should say A2 minus A1 is definitely not equal to A3 minus A2. Or you can also write A4 minus A3 is not equal to A5 minus A4. Okay. So which means this will not form an AP. No. So this does not come under arithmetic progression. Okay, clear? Now the last example. What is the last example? Okay, last example is triple one, triple two, triple three, and so on. So example number 4. So the series is actually 1, 1, triple one, then again 2, then 3, 3, 3, and so on. We will just write, okay, now this is A1, A2, A3, A4, A5, A6. So we are getting a lot of numbers here, and A7, A9. So obviously the getting the first term is very easy. Now A1 is equal to 1. Now let's find D. So D will be A2 minus A1 or A3 minus A2 or A4 minus A3, or it can be A5 minus A4. We'll add one more thing also, or A6 minus A5. What is A2 here? So A2 is 1. So 1 minus 1, which is equal to 0. Okay, now what is A3? So A3 is again 1. 1 minus 1. Again, this is 0. This is A4. A4 is 2. So 2 minus A3 is 1. So 2 minus 1 become 1. Okay. Now A5 minus A4. That is 2 minus 2. Again 0. Okay. Now A6 minus A5. So again 2 minus 2 is actually 0. We will just try two more things also. Okay. So now again A7 minus A6. Now what is A7 here? A7 is 3. So 3 minus 2. So 3 minus 2 is again 1. So if you notice here, the D is not same. So if the first two it is 0, then again it's 1, again 0, 0, then 1. So obviously this does not form under AP. For an AP, the D should be same throughout the series. Okay. So this does not form under the category of arithmetic progression. Fine, clear? Easy? Hope the explanation is easy for you. In the next video, we will be starting with exercise 5.1. Okay. If you find this video useful, please subscribe to my channel. Meet you in the next video. Until then, take care. Bye bye.